Whew, here we go, day 6. Just want to make sure that this works. I'm going off by 1. Wait, this doesn't seem right. Oh, I see. Rank 64. And rank 35. Whew, that was a really quick day, I feel. How long did that take? Oh, I guess it was a whole 2 minutes. Still pretty quick, though. Yeah, so, what happened there? I could have been way faster with that. Yeah, what happened was, I wanted to use the test input because, I don't know, I just wasn't confident I was understanding it correctly. I'm pretty sure I read this and I immediately thought, like, oh, look for the earliest location where we have, like, 4 distinct characters. But then I think I saw this and, like, I don't know. I was worried about off by 1s. As it happened, I was actually, like, off by 4 initially, because I was printing the number of characters you need to, like, remove before you see a start of packet marker. But it wants you to, like, count the ones that you process, which makes sense. I think, like, the wording is definitely unambiguous. But I wanted to be careful to not get a lookout there. And I think that paid off, probably. I mean, 60 is for sure not the greatest. Like, I'm probably going to fall in ranking a little bit from that, I think. But I think if I had submitted something wrong and been locked out, I definitely would not have leaderboarded for part 1. So let's take a look. Still number 7. I think things have probably filled up by now. Yeah, they have. Okay, cool. Yeah, I guess now that I'm tied for 7, I technically fell, like, a little bit. But yeah, holding my position is pretty good. I'm decently happy with that. I'm for sure happy that I didn't submit something wrong and get locked out and lose, like, a lot of position on the leaderboard today. Cool. Yeah, so I guess I'll go ahead and explain the question now. I mean, I've kind of been explaining it in that little commentary there. But basically what it is, we have this long blob of characters, and so basically it's like, I don't even know what the setup here is, but I guess, like, the whole problem we're looking for is we're looking for the first location at which the next 4 characters are distinct, meaning you don't have any duplicates. And this could happen at the very beginning. Now, in this particular string, it doesn't, right? Because j is equal to j, so it doesn't happen here. And then you move one letter over. And again, j is equal to j, so it can't be here. You move, like, another letter over. It's like a rolling window of size 4 or something. And then here, q is equal to q, so it can't be this one. But then here we see 4 unique characters, j, p, q, m. So this is, like, the first time we find our distinct 4 characters. and we had to read a total of 7 characters in order to get here. So the answer for this input is 7. That's basically what the question is asking, and I did this in like a not super like clever way. I mean, I'm basically just checking like, oh, are the first 4 characters unique? If so, whoops, I need to, for this to work correctly, yeah, I need to duplicate this. Well, anyways, if the first 4 characters are not distinct, then chop off the first character. It's what this does in Python, slice notation, add 1 to a counter, and when I'm done, I print the counter +4. And it's +4 because like we need to include the next 4 characters. So if we like cut off 3 characters, then I would be 3, but we need our answer to be 7. So that's all there is to it. I am making like a little minimal edit here, so that this will run properly with both parts. Yeah, oh, and then part 2 is much the same, except now instead of 4 characters, it is 14 characters. And I think if it were something like, what's reasonable? I think even 1,000 would be like really fast. If this input was longer, like here, we can take a look. This input is only 4,000 characters. I think if the input was like a good bit longer, and this window was a good bit longer, this might be like too slow. Like there's another approach you can do, which I'll mention in a second. But like for 14, this is for sure fast enough. Like you can sort of see this runs basically instantly. So yeah, I'm a little surprised that I moved up that far on the, like, I guess this was a 13-second split, which is pretty fast. But for sure, I think once you see part 2, it's like just 14. You just change a number and you're good to go. I'm not sure if I did this or not, but I guess you could also just add a 1, which is even faster than change it to like 13 or something. But yeah, that's the question for today. Yeah, all there is to it. I guess real quick, I'll talk about, oops, let me fix my scaling here. I'll talk about the alternate solution real quick. So another thing you can do is you can maintain a dictionary. So like you keep your current window. We'll do this. And your current window is going to store like, it's going to have keys that map to counts of each character. I'm going to use like an actual dictionary. If you knew that these are all like lowercase characters or bytes or any other like specific thing, you could make like an actual array with like 26 entries or something, which would be like a little more efficient. But it doesn't really matter for the sake of just demonstrating this approach. And what you can do is you can, so basically with this, at any given point, this window is going to map like a character to the number of that character in this window. And what we're basically looking for is the first time when there are like 14 different keys in this window. And what we can do is we can roll the window over by 1 by removing the last character and adding the new character. So what do I mean by this? In like this case, for instance, let's do. So this here represents like the window. So this is gonna be the first window. And when you want to roll the window over, we simply shift it over by 1, and we remove the M from the window, and we add the D. So this is going to be remove M, add D. And this is like a sort of classic approach that I've used in a few different questions. And yeah, it looks something like this when we code it up. So first, we need to populate our window with the first 14. So now we have the first 14. And then what we're going to do is we're going to roll until her window has 14 unique elements. So while the number of keys. You can just do len of the dictionary too, but doing keys is like a little bit nicer because you can actually see what it's doing. Well, this is less than 14, and we'll do like next index. It's going to be 14. So roll the window by 1, adding next index. I think my camera's probably getting in the way, so I'll scroll down a little bit. And the way we do this is we're going to say if s of index window. I could maybe make this a little bit cleaner by using like a default dict or something, but just for sake of example, I'm not doing this for speed anyways. I'll just use a regular dictionary. Yeah, so if it's not in the clear window, then we add it. And we need to also delete, so we need to add next index, and then we need to delete next index minus 14. Because if we're adding element 14, well now the window is length 15, so we need to remove the thing at 0 in order to make sure this window is always length 14. And we will do next index minus 14, minus 1. We know that this key has to be present because it was in our rolling window. It could not have not been present. And now we do if this is 0, we need to delete the key from the dictionary. Cool, and then we increase next index by 1. And now, it's worth noting that I think we don't need to add 1 to this. The way that I like to think about this is I like to think about what if we were already at 14 unique elements? Well, next index is already 14, so and that should be the right answer because we looked at 14 elements. Really, there's like sort of 2 off by 1s canceling out here, because next index is 0 indexed. So this would be like 1 higher. Like it's not actually the index of the last element that we're including, but because it's 0 indexed, it's like the number of elements. It actually ends up being the number of elements that we have looked at as well. So this just ends up being fine. And if I do this, yep, we get the right answer. Cool. That's all there is to it. I think definitely like this other solution is, I won't say tricky. I think like once you understand it, it's not too hard, but it's not something that comes up a lot. And I think if you've seen it before, it's a lot easier to do. I'm almost a little bit sad that the numbers here were like small enough that just doing the easy thing was very fast and sufficiently fast. I think I like a lot of puzzles in additive code where part 2, they amp up the numbers and they actually require you to do like a smarter approach. But all in all, I still think this is a decent question. I think definitely it's a good way to introduce people to this technique if they haven't seen it before. I'm sure some people will be posting about it on the subreddit or something. But yeah, that's it for day 6. I will call it here.